So now you can see at one glance what data is hindering the delivery of the Easter eggs and which data have to be cleaned, which data is just causing additional work. And I think this is a pretty good starting point to measure data quality. Today, I will show you how you can build a data quality dashboard for the Easter Bunny, because you know the Easter Bunny did a lot of sales before Easter, but the bunnies did not track all the data quality, so some deliveries are not possible at the moment. And I use this example to show you some approaches how you could build a dashboard that is measuring data quality. So you do not calculate something out of your data, you just measure the quality of the data that gets into your dashboard. The file I'm using for this can be found on my GitHub, and the link will be in the video description. So let's jump into Power BI now, and I will show you how you could do that. So here we are in the data quality dashboard for the Easter Bunny, and you can see here some things. In the dashboard, there are more or less two tables that are input tables. So one times the rabbit table, and in the rabbit table, there are the states and the responsible sales rabbit. And there is a second table, the Easter order tables. And in the Easter order tables, you can see the row ID number, the order ID, the order date, the delivery time, the color, the delivery place where the X should be placed, the customer who was ordering, the city, the state, the country, and the quantity of the X. And as you can already see here, there are some problems in this dataset because the delivery time is not right or is missing, the order ID is missing, the color code is not right, the delivery place is missing or misspelled, it has some trailing blanks. And also here you can see that the customer ID is missing and the quantity is a minus quantity, sometimes it's blank, and so on. And these are the things we want to measure. This KPI is indicating that 68% of the data are corrupted, and for 36% of the data are causing an impossible delivery, and only 32% are causing additional work. Then here you can see the rabbits, the sales rabbits, and their data quality fails. So you can see the puzzle has 44 rows or to clean more or less. And these 44 rows are 65% of his sales volume. So from all the data he's responsible for, 66% are wrong. And here you can see the sales rabbits table. And in the sales rabbits table, you can see that 29% of the data are wrong or do not have the data quality we want to have them. And here you can see that I only checked for the key because I need a unique key to connect to the Easter eggs table where the orders are. And you can see that these two rows in the state column are not unique. And down here we have the Easter orders table. And for the Easter orders table, you can see that the data fails are 68%. And you can see here the table name, the column names, the percentage of the missing values, the percentage of the wrong values, the effect on the delivery, because for some rows, maybe the delivery won't be affected. And here you can see then the affected row IDs so that the user knows which rows have to be cleaned. And this is more or less what I will show you how to build it. And you can see that there are some additional pages, and the main page we will need is the columns, because you need to create these first. And how is the column created? The column overview is created by using an info view function. So you only use the info view function for the columns, and then you get this table, and out of this table you can choose the columns you need. So the table, which is the Easter orders, the name, the description, and so on. And what I did first, I created this and copied it over here and put in the table and the name of the column, because I need this to point out these values. And for pointing out these values, I will use some switch measures later. So what did I do here? You can see that here's the table name, the column name, the missing values, and the missing value is the first measure I created. And this measure can be found in the Easter order tables, in the missing values. And now you will see what I did here. For the missing values, I defined first the table name. It's the Easter orders, because in the result, I'm checking if the columns table selected value, so the table name is Easter orders, and if the selected value for the column name column, so the name of the column is city, and if it is like that, I will get the check for the null of the cities. And the null of the cities is a count blank for the Easter order city column divided through the count rows of the Easter orders. So I'm dividing the number of the blank values through all the row numbers. And by doing so, I get the percentage of blank values. And I'm doing this for all the columns, and with the switch, I sort them in the place where I need them. So this is how I got the first column with the missing values. The second column with the wrong values is no more so easy, because for the wrong values, I will show you, you have to define some rules. So you have to think about what does it mean if the value is wrong. So you can see here again that I'm calculating some variables and I get some results then. And at the end, I do again use a switch to sort in the results in the right row. So what did I do here? So for the blank values and the non-distinct values for the cities, I created this, and I will show you what this is doing by copying it into the DAX query view. Because for this exercise, I tell you, the DAX query view will be your best friend, because you can immediately see what's going on there. So we will copy this over and go to the DAX query view, open a new tab, type in evaluate. You need this, that the DAX query view is doing something. Ctrl V, put in the code, and then you need a return, and you can return the table city errors. By doing so, you will see that you get this table. And what you need to know when working with DAX query view, you need to know that you always have to return a table. I will show you by copying out this again and put it in here. And here you can see the first thing I'm doing is I'm summarizing a table. And summarizing means I'm summarizing the Easter orders table. And in the Easter orders table, I'm summarizing the row ID, the Easter orders city. So if I click, no, I need a return first. So I go to return, table city errors. And if I click on run, you will see that I get a table with the row IDs and the Easter orders for the cities. What I want to check now is if the city names are correctly spelled. So let's say if there are trailing blanks, and so I have to check the length of this city name. To do so, I need to add a column in this function, and for this I will go to add columns. I will need a comma here, go to the next row, will call it length city, and it will be the length of the city, and then I have to close it with a bracket. If I run it again, you can see that I see now the length of the city. And what I need now also is a second column with the trimmed length, because the trim will remove the blanks at the end and the beginning. And for that, I will add here a trim, close the bracket, remove that, go to run. And then I can see here also the trimmed length. And what I need to check now is if the trimmed length and the city length is the same. Because if it is like that, then I know that the name is written right. For that, I will also need another add columns here. And I want to insert now an additional column that is called error. And I want to check if the length of the city is the same as the trimmed, I need an if, then it is no error, so we will return a no, and if it is not the same, we will return yes, and we will know if it is an error. And now I need also here a bracket. Click on run. Something went wrong now. Here's the mistake. So if I go to run now, you can see that there is written it's an error or it is not an error. And the next thing I want to do is I want to filter down this table by the errors. So I will need a next variable. So I will call it filter table. And for the filter table, I will filter the table with the city errors. And now I need the filter expression. I want to have all the rows where the error is. And I have to copy this down. Click on run. And now you can see that I do not get any value because in the cities table there is no error. But if we click now on no, just to see what's happening, you see that only the rows with no error is returned. So you can see that no city has an error if I only check the length. And here check is blank. And the check is blank, well, is blank, the city. And then I will click run. And now you do not see something because we need a second criteria here. So we will use here a switch. We will set it to true. Say the length of the city is the length of the city trim. Then we will say no. And the second criteria is the is blank. The check is blank is true. We will return a yes. And we will change this here also to is not. And we will also return a yes to make it more readable. And in all the other cases, we will return a no. Then you go to run and you will see that there is one city value which is not working because it's blank. You can see that the length is not given because there is no name, so there is no length, but the value is blank. So the next thing what you can do now is you can count these rows. So you can add a count rows and add a bracket here and go on run. And now you will see that you get an error because in the text query view, you can't see it if you do it like that. So you have to add a row here. Name it just result, add a comma and a bracket here, and then you will be able to see it again. And you can see that the result, if you count it now, is 1. So the next thing we will add here is we will add all the rows of the Easter table. So we will name it variable all rows. And all rows is just the count rows of the Easter orders table. And now you can divide the count rows of the filter table, which is yes. So you can divide, we will name it like that again. And now we will take it result. Result is the row, name it result, and it will be a divide the filtered table by all rows. And here you need to copy that down, go and run, and then you can see that 1% is missing. And then I took this and copied over into the DEX function for the wrong values. You can see it here. And then I get the variable with the wrong cities, which is the filtered city errors, which was the count rows, where the error is yes, divided by the count rows of the Easter order. And what I could also have done here is I could have taken it out in all rows here, because then it does not have to be calculated over and over again. And take this here and put it here. This would have been a little bit more elegant and performant. And then I'm doing this for all the columns I have. So I have to think also for the color, how does error look like? So for the color, there can be the hashtag missing, and the length of the color with the hashtag should be 7. So what I did here also, again, I summarized the Easter orders, the row ID, the order ID, and the colors. Then I checked the length of the color, and I checked if the string contains hashtag. If yes, there is a 1 returned, and otherwise a 0. And then I'm also again adding a column for the error, and for the error I say the length is either 6 and the hash is 0, then I will return a add hash, and otherwise the length is 7 and the hash is 1, it's no error, and in all the other cases it is an error. Then for the country, I know that the orders are all from Austria, so I'm just checking all the rows where the country is not Austria and return also then this percentage. And for the customer ID, I just know that there should be 1 minus in the customer ID because more informations were not available. So what I did here is I did also summarize this table to make it a little bit more readable. And then I was counting the number of these delimiters. And to do so, I calculated first the length of the customer ID, subtracted the length of the customer ID, where I substituted all these minuses with nothing. So in the string, all the minuses were removed. And I know that if this value is not 1, because I should have 1 minus in the customer ID, it is a mistake. So these are the wrong customers. And this is how I went through all these columns and defined the criteria. So for the delivery time, I know that it should be able to convert the time into a number which is between 0 and 1. So for the delivery time, I summarized the orders, the customer ID, the order ID, and the delivery time. And I checked if the delivery time is a number or not. And I took only out the mid value because I know that also the date, as it is a date time column, I can show you here. You can see that the first characters are the date, the month, and the year. So we do not need that. And only this part we want to have. And this is what I achieved with the mid. So I said I want to have the mid part of the string from 12, and I want to have 8 characters, and this should be convertible into a number. And if it is not working, it will return is error is true. And then I was also checking again for the blanks, and I added again a column with the error, which says if it is blank or if it is not a number, it's an error. Otherwise, it is not an error. And this is how I went through all these columns and defined some criteria. And here you can see the result, and the result is, like I said before, the switch function sorting in these values. By doing so, you will get this column and the percentage in these columns. And then you have to define the effect on the delivery, because maybe there are missing values or wrong values, but it will not affect the delivery. And this is what I checked here. And here I was just saying if the missing values are bigger than 0 and the wrong values are bigger than 0, then for the cities you should say no delivery possible. Because if they're missing or wrong, the Easter Bunny has no idea where to bring the Easter eggs, and they will not be delivered. So for the color, I also said if there are missing values or wrong values, the best selling colors will be sent, because this is not such a hard criteria. Maybe they will not like the colors, but you could also say here the customer will be called if you know the customer or something else. And for the country, I only said if the missing values or wrong values are bigger than 0, I will check if the city is in Austria. And this is also how I went through all these cases. And you see that only some cases, like the city, the missing customer, and the quantity missing, will affect the delivery. and all the others can be solved by working on the data. And the last step I did then was I wrote a measure to find out which rows are affected, because now you have to clean the data and nobody knows how the wrong values are. For doing this, I also wrote a measure, and the measure is here. And you can see that this measure is doing more or less the same like I did before. So for the city errors, I'm building up this table. Then I'm filtering down the table for all the error rows. Then I'm selecting only the columns out of this filtered table, so the table where only the errors are in. I'm selecting the column with the row IDs, and then I use the concatenate X to concatenate all the row IDs I have in this column with a comma into one cell value. And I'm doing this for all the columns. So I get a complete list of row IDs that are affected in here. And you can copy out this row IDs by clicking on the cell, on copy, and copy values. And the next thing what I had to do is I had to find out how many distinct rows are affected. To do so, I also wrote a new measure. I think you already guessed that. So the affected row number is this measure. And this measure is nearly the same like the one before, because here I copied the measure with the affected row IDs. And here I have these variables for the columns with the city errors. This one could be deleted because they are not needed in here. And if you scroll down at the end, I'm combining all these affected row ID lists. So all these columns with the quantity errors and so on. I'm using a union to create one column out of them. And before I wrote a distinct to get only the column with the distinct values. So I will use a counter on the combined IDs so I can find out how many IDs are affected distinctly, and I can affect and I can return the number of these affected rows. And what I did then is calculated the affected row percentage by calculating or by using a divide the affected row number by all rows. And here you should also consider the other tables, but I know that in the other table there was only one value wrong, so I did not add it here, which is not completely correct, but it is the job. So I hope it's clear now how this part was built. And after I build this part, I can build also this part, because for building this part, I need to have the affected rows and rabbits, which is a table. So you have to go to modeling and to new table. And by doing so, I was building this table. And this table is more or less, again, the measure that checks for the wrong values. But at the end, I added something, because here you can see that here are the combined IDs. So the IDs we used before. And here I'm combining them with the sales bunny. So I'm creating again a table. I am filtering down the Easter orders table for all row IDs that are in the selected columns, combined IDs, row ID. So in this column, and then I add to this row IDs the salesperson. I can do that because the tables are connected, and the salesperson are the related rabbit in the sales rabbit stop. And the salesperson is the sales rabbit in the rabbit table. And afterwards, I'm selecting columns. I'm selecting the row ID, which is the Easter orders row ID, and the salesperson, which is the salesperson's. And I return this result, and by doing so I get this table. So you can see that I have a table with the row ID and the salespersons now, and then I wrote two measures. One times the number of the affected rows, which is just counting the sales rabbits and the affected orders row ID. Then I was also adding here a measure for the total rows, and then I could calculate the percentage of the affected rows, which is the number of the affected rows divided by the number of the total rows. And here I added some formatting on the result because I wanted to have it in a percentage and in this format because I will add this as a detail in here. So because in this visual, if you go to the data labels, you can see that the value is the number of the affected rows and the detail is the percentage of the affected rows, which is the last part that I showed you before. And in this bar chart, you can see the affected row percentage and the not affected ones. So you can see immediately how this table is performing. So now we will come to the easy part, because the easy part were the sales rabbits table, because in the sales rabbits table, I was only checking for duplicates, which was pretty easy compared to what I showed you before, because for this, I just wrote a measure, and this measure is taking the current selected value for the state, it's trimming it, and it's putting it to lowercase. Then it's checking for duplicates by filtering the rabbits table, and the rabbit filter table is filtered down for all the values that resemble this value. And then it's returning the duplicate count bigger 1. If you do so, you can create then a table with the state and the duplicate sales state column. So now you can see at one glance what data is hindering the delivery of the Easter eggs and which data have to be cleaned, which data is just causing additional work. And I think this is a pretty good starting point to measure data quality. So I hope I could show you how easy it could be to create a data quality dashboard. And I hope you also liked the video. Don't forget to leave a thumbs up if you liked it. And if you're celebrating Easter, I wish you also a happy Easter. If you're not celebrating Easter, you should just use it as a good excuse to eat a lot of chocolate. So I wish you a great day now and hope to see you soon. Bye bye.